So this, guys, is the last thing we're going to do. It's nothing new. It's just, think of it as like the word problems of using sine and cosine, and or maybe your SOHCAHTOA. Okay? So I'm going to talk a little bit Tuesday on ambiguous case of sine law, but some of you noticed we kind of just skipped over lesson 7. We're going to lesson 8. Okay, this is what's going on next week, right? Monday's a holiday, of course. Tuesday's review day for your trig test, which is the 13th. 14th, one-day review for midterm, but a lot of us just had rewrites. Okay, so that's one chapter you hopefully don't need to re-look at. Okay, but you got 2 more. And trig, I'll hand those back on the 14th. Look over those, midterm Friday. Okay? So, further applications. This is handy. On the test, it's not going to say use cosine law, use sine law, or maybe use grade 10 stuff. You got to know what to do. Okay, so just like, remember our little flow chart in factoring? And even after, well, just before the rewrite, I was still referring some people. You remember that little flow chart I said that was kind of handy? That's what you do. That's how you know what to do when you're looking at a problem. How do I factor this? Okay? This isn't as big as that flow chart, but if it's a right angle, why use sine law? Okay? Use SOHCAHTOA. Don't forget the grade 10 stuff. In a non-right angle triangle, of course, you can't do that. Okay? How do you know whether to use cosine law or sine law? Here it's telling you. If you got a triangle and you're given side, 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 can you use sine law? You could try it, but it's not going to work. Side, 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 you use cosine law. Okay? Or if you're given this side, angle, side, it's not going to work if you use sine law. That's when you use cosine law. Okay? Those two situations, side, 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 angle, side, but the angle has to be in between the two sides, right? It can't be this angle. That's not in between these two sides. Okay? So again, I gave this visual thing with my arms and my head. Side, angle, side. All right? If you don't have that, then sine law. Okay? I'm not going to give you one you can't solve. So don't think of that, okay? So, I know this used to be in grade 11, the old, I told you that in grade 10 too, right? Okay, it used to be the old grade 11 curriculum. We used to spend 2 weeks with circle geometry. Kids liked it. It was a lot of fun. This is visual, like kids in foundations. It's a lot more visual. They're like, hey, this is cool. Okay, now they bumped it down to grade 9, and then we're, left to the grade 9 teacher as to how much of this they actually do. So no, I don't expect you to remember all this stuff. Okay, quickly, the perpendicular from the center of a circle to a chord, center of a circle to a chord, bisects the chord, and of course it makes a right angle when it does it. If in grade 9 you got some good cool problems like this, we would have given you the radius of the circle and said, well, where do you want to draw a radius that's going to help you solve this? Does that help? No. But this one sure does, because now you got a right angle triangle. You can use Pythagoras. And that's probably the only time in grade 9 you use Pythagoras. Okay? There's a relationship here between these angles. This angle in the center that's subtended by some chord is twice the measure of the angle that goes to the other side of the circle. I don't care where it is. Always, always, always. That's a relationship. Okay? So, the measure of a central angle, the one to the center, is always twice the measure of the inscribed angle subtended by the same arc. Lots of wordage there. Okay? But a picture is worth 1,000 words. The inscribed angles subtended by the same arc are always equal. This is equal to this. It's equal to that. I don't care where you put it. It's equal to that. Okay? Yeah, Meryl, did you do this stuff? Yeah. circle geometry? Yeah, okay. A tangent to a circle, there it is perpendicular to a radius at the point of tangency. Always, always, always. Perpendicular. Okay, so quickly, just kind of like that's supposed to be a review, but you know. All right, so again, I'm not going to expect you to know this stuff. Here's something else. If I draw a chord through a circle and it happens to go through the center, there's another word I can call this. What is it? It's a diameter. When you subtend some angle from that diameter, this always makes a special angle. Any guess what that angle is? Yeah, okay. Don't draw this, but I don't care where you put it. Over here, that's a right angle. Anywhere on that circle, if it's subtended by a diameter. So, if you don't know that, I'm telling you. O is the center, yep. It's a circle of radius 3.25, so do I know this length? I hope so. QR is 2.5, and RS is 4.7. What's the length of PQ? Draw yourself a new picture. I'm going to draw this. Okay, do I know how long that is? Yeah. It's 6.5, right? Because the radius is 3.25. This is 2.5. Doesn't really look like it, but that is my right angle. Okay? Can I find this length, PQ? Sure. Okay? Is that a right angle triangle? All right. How can I find that? SOHCAHTOA? Or is there another relationship with right angle triangles? Like this one. Don't forget about Pythagoras, right? Which one's the hypotenuse? Yeah, and again, my picture is bad. It's always opposite the right angle. 6.5 squared is, doesn't matter which leg is which, plus x squared. Solve that thing for x squared. Okay, you might have wrote it like this right off the bat. X squared is c squared minus b squared. Okay, put that in your calculator. I'm sure we can do that. And x squared is 36. So x works out to something nice. Do I have units? Yes. Okay, 6 centimeters. QPR. Where's that? That's this angle over here, okay? That's this guy. That's angle Q, let's call it just angle P, okay? Because that's the one in the center. That's angle P. Okay, I got a right angle. Feel free to use sine law, but use SOHCAHTOA. Do you want to use X? I said this in grade 10 too. What if you made a mistake here? If you use that in your value, right? Maybe now you're going to have, this one's going to be wrong too. Use what's given originally. What ratio has opposite and hypotenuse? Sine of P is opposite over hypotenuse. Inverse sine of that ratio is going to give us our angle, right? And if we do that, we get 23 degrees. Then you look at your picture. Does that look reasonable? Okay, sure. If you got like 110, gotta ask yourself something, right? Okay, S, Q, R. Well, let's skip that one because again, we're talking about, that's the same angle as this one, so that's 23, but I'm just going to tell you that, okay? Because again, I don't know how well we know our circle geometry. That's the angle we're trying to find. Well, let's not worry about that right now. Okay? Bearings. That's one way to use our compass That's one way I'm not going to tell you about. Okay? Here's another way. Before I do this question, we need to know how to do this. I'm going to change it. Okay? I'm not going to teach you 3 ways to use our compass. In physics, we do one way. We teach it. Okay? We learn that way. Okay, this is similar to that. Alternative way of describing a direction. Okay, well, let's change that. There, that's better. A way of describing a direction. Okay? So here's your soggy wiener thing. I hope we can all make a compass. This isn't on your formula sheet. North is always up, south is down. What does this spell? We, not you. Okay? A bearing of, don't worry about this, 55 degrees east of south. That means you're due south, and then you go 55 degrees east of it. Okay? That's the way we did it in physics, but I'm going to actually tell you a different way to do it. This, I think, is more meaningful. That's the same as south and then 55 degrees east. Okay? So this is how we're going to do all our problems in this course. Okay? So due south, then I go 55 degrees in the east direction. Okay? So it's laid out as you read it. Everybody see that? Okay. So what would this be? This would be due north and then 60 degrees east direction. Okay? This is due south and then I go 60 degrees west. All right? So this is due north and then 20 degrees in the west direction. North, 20 degrees west. Okay, let's do another one. Let's go west, 40 degrees north. How would I do that? This spells we. Start here. That's where I'm headed, but I'm going to go 40 degrees in what direction? North. Okay? So there it is. What would this angle be? Yeah, 50, right? Because of course these all make right angles. Okay? So let's backtrack and look at this guy, but we're going to change our question a bit. A liner leaves a port P, there it is, and sails 15 kilometers on a course 37 degrees to a position Q. Let's go north 37 degrees east. Okay? Where it changes course to, we're not learning it that way. Due west. And sails 12 kilometers to position R. Complete the sketch to illustrate this information. Calculate the distance the liner must sail to go from R to P. Okay, that's what I want to find out, this length. So, let's start again. A liner leaves port P, okay, and sails 15 kilometers on a course north. That's north, right? Straight up. 37 degrees east. Okay? So there it is. So they're kind of helping us out. They drew the lines already. To position Q, where it changes course to due west. Well, that's west, isn't it? Okay, so he sails 12 kilometers. I didn't put my 15 there. To position R. All right? And then he's going to sail back to where he started from. So he's making a big triangle. I need to find x. All right? So my brain tells me if I had this little angle here, I would have this whole angle, and I have a side opposite to it. Think sine law. I could find this angle here because I have the side that. I got 3 pieces of information if I had that, but do I have that? What do I know here in this triangle? Hang on. Let me just emphasize something here. These are all right angles, right? Okay, do we see a right angle here somewhere? Ah, there's one. How does that help me? What's this angle? How many degrees are in a triangle? 180. So 180 minus 90 is 90. Minus 37 is, yeah, okay. There's 53 degrees. Now I have an angle opposite the side I want. Cool. Is there another angle with the side opposite it I can find? Or is there another way to find that side? When can I use cosine law? When I have all 3 sides, I can find an angle, or if I have 2 sides and the angle in between them, I can find the opposite side, can't I? Do I have what I need to use cosine law? I sure do. I have a side, angle, side. Side, angle, side. Cosine law, I got x, okay? See, it's easy when the whole lesson's cosine law, but now you got choices to make, and I see people getting hung up. I want to use sine law, I want to use sine law, No. Open your mind, right? What do you need to do cosine law? Okay, so anyway, x squared is 12 squared plus 15 squared minus 2 times 12 times 15 times cosine of the angle in between. Do I need to do that in my calculator, or are we okay with this? Just remember to take the square root. Okay, the more decimals, the more accurate it's going to be. So x is 12.34. Okay? That's the distance. Did I answer the full question? Okay, that's what x is. Oh, and the course. They want to know what this angle is. They want to know what direction to head to get back here, because you can't see point P. It's a wide open ocean, right? They have little instruments on their ship that'll do that automatically, but let's pretend it's the 1700s. And you got a little, what do you call it, a sexsmith? And you got to look at the horizon and try to figure out what direction to go, okay? That's right, isn't it? Sextant? Sextant. All right, forget it. All right, whatever. I'm having some issues this morning. Okay, how do I find out that angle? Sine law. Okay, I need this angle, I need the side opposite. So the sine of r over 15 is the same ratio as the sine of 53 over the side opposite it. That's why I didn't round this to 12, because that will throw my angle off here, right? Why can't I use 12 in this angle? Because I don't have this angle. It has to be the whole angle of the triangle. I don't know what this is, right? And I don't care to find it. This is the only option you have, okay? Use that what you just got. Okay, so the sine of r is get rid of 15. Whatever you do to one side, do to the other side. 15 times sine 53 divided by 1, 2, 3, 4 with a decimal halfway. Okay, and that should give you, take the inverse sine, I don't know the angle, 76 degrees. But if I'm going to be consistent with my directions here, that's not just any old 76 degrees. How do I label this? That's 76 degrees. So this is due east, and then I go 76 degrees south of that. Okay? All right? So there's due east. If I go 76 degrees south of that, that's what this line is. Okay, that's not big enough. Okay? Okay, I don't think I want to give you this one. So, you got lots of time to practice. We got to fix one little thing though. Nope. And I should show you something else. Because a lot of us forget how to read these things. Well, no, I'm just being sarcastic. Okay, let me fix this. Change this angle ACD to angle ABD. Okay? Because I don't know if we know those are the same angle. Change this. ACD to ABD. Okay? Sorry? Yeah, it's going to be the same. Because that's the same angle. Yeah, that's why I'm changing it. So you can look at your answer and see if you got it. Okay, so clocks. You guys know how this clock works? Do you know how many degrees it is in between each hour? Okay, how did these guys get that? How many degrees are in an entire circle? How many increments do you have? 30 degrees. Okay? That will be helpful for the last couple of questions.